Okay, so this is the key to topic 17, and this is the worksheet called Extra number 9. And in these three problems, you have rational equations, and you're asked to solve each of those rational equations. Now, notice it says this: use the method of clearing the fractions denominators using the LCD. So make sure you understand what was meant by that, either through the lesson or through that sample work that was provided in Canvas. All right, so make sure you are following these directions here. And then you circle the solution. If there's no solutions, just say no solution. And then I need for you to indicate the LCD. Now this one's the easy kind because if you notice if you look at all these rational expressions, except for this one where you have 1 over 1, um, the variable expressions are all the same. I'm going to use the word variable expression. This is x plus 9, this is x plus 9. This is x minus 3, this is x minus 3. This is x minus 7, this is x minus 7. All right, so your least common denominator, since all you have are variable expressions, and then the other denominator, see this one, that's 1 over 1, that's negative minus 4 divided by 1, and that's x divided by 1. So they're all 1s. All right, but so 1 is a factor of every denominator, every common denominator. Okay, so your least common denominator in this case is just going to be x plus 9. That's your first one. All right, so if I look at number 1, go ahead and rewrite number 1. We have 3x divided by x plus 9 plus 1 equal x divided by x plus 9. All right, so once you know your least common denominator, which in this case is x plus 9, then the next step is to multiply both sides by the LCD. So that's the next step. That's the method of clearing the fractions denominators using the LCD. Before we go on, though, we got to look for the restrictions. Let's determine the restriction. So the question is, what makes this denominator 0? So remember, whenever you have a rational expression, you cannot divide by 0. So remember, rational expressions, you can't divide by 0. That makes this undefined. Okay? So you got to ask yourself, what's going to make this denominator 0? So if you think about x plus 9, remember they're both x plus 9. This denominator here, I'm going to let me go ahead and rewrite this so I can show you what I mean. See this 1, I can write 1 as 1 over 1. So this is never 0. That's always 1. This can be 0, and this can be 0. Okay? But this one's never 0. So the question is, where is this 0 and where is this 0? Well, they're the same, so you just have to do one of them. So the question is, where is x plus 9 equal to 0? Well, x plus 9 equals 0 when x equals negative 9, right? Negative 9 plus 9 is 0. So you're just taking this factor, set equal to 0, and solving this linear equation. So your restriction is that x cannot equal negative 9, because if x is negative 9, this is 0, and this is also 0, and you cannot divide by 0. Okay, so now what I'm going to do now is I'm going to now I put this extra thing there and I wrote on it, so I'm just going to go ahead and just kind of do this. I'm going to go ahead and rewrite this over. So 3x divided by x plus 9 plus 1. Now remember, the whole point is to multiply both sides by the LCD. So since I have two rational expressions here, I'll put that in parentheses, and I'm going to say times x plus 9. Same thing here. Over here, x divided by x plus 9 times x plus 9. Okay? All right, now I'm going to distribute here. So I get x plus 9 times 3x divided by x plus 9, just like this. So remember, every rational expression has to be multiplied by x plus 9. So this has to be multiplied by x plus 9. Plus 1 times x plus 9. Now I'm going to come back, I'm going to fix this because I need for you to be careful here, because this is what some of you are going to do, and you got to be careful. Now this, you're not going to make a mistake here because this is a 1, but if this is a 2, you could easily make a mistake. Equal, and then the third, the rational expression on the right side times the LCD. Okay? Now, technically, mathematically, there are some things wrong with the way I wrote it, and so I need to tell you that. See this right here, when you write it like this, you're saying the only thing that's being multiplied by x is by 1 is this x, when actually this whole thing has to be multiplied by that. Right here, when you write it like this, you're saying that only 9 is being multiplied by this rational expression, when this whole thing has to be multiplied by it. And the same thing here. This is only being multiplied by x, when this x plus 9 has to be multiplied by. So it's important that you understand that these variable expressions here really should be put in parentheses, because this whole thing is together. And so this x plus 9's divide out. So remember, the whole point of multiplying by the LCD is to make these factors 1s, and then these divide out as well. Now be careful with this one. So this is a 1. You're not going to make a mistake because it's a 1. But if it's a 2, you have to distribute the 2. So here I have 1 times 3x is 3x, plus 1 times x plus 9 is x plus 9, equal, and then x times 1 is x. Okay? Now notice I went from a rational equation to a linear. So 3x plus x is 4x. I get 4x plus 9 equal x. Let's go ahead and subtract 3x from both sides. 4x, subtract 4x from both sides. Subtract 4x from both sides. 4x minus 4x is 0. 0 and 9 is 9, equal. X minus 4x is a negative 3x. Okay, be careful, negative 3x. Divide both sides by negative 3. And then reduce, I get negative 3 divided by negative 3 is 1. 1 times x is x. So I get x to be 9 divided by negative 3, which is a negative 3. Notice, though, that is not a restriction. So as long as I did this work correctly, this is a solution. All right, so that's the answer to number 1. Okay, let's look at number 2. Number 2, we have this. In number 2, we have 3 divided by x minus 3 minus 4 equal x divided by x minus 3. Now the difference between, well, if you look at numbers 3 and 1 here, they kind of have the same format. A rational expression where you have denominators involve variables, then plus a number, minus a number, and then the same thing here. So they almost look the same form. But you got to be careful with this subtract 4. See right here where I told you at first, if you forgot to put parentheses, it would not matter, because 1 times x is x, x plus 9 is still x plus 9. You got to be careful with this subtract 4 here, because if this was subtract 4, you'd have to distribute the negative 4. So that's why that parentheses is important. So you're going to see that again when we do number 2. So number 2, we have this. So notice, though, that the denominators are all the same. See that? So they're all x minus 3's. And I cannot factor x minus 3. So I'm done in terms of factoring. So I know my LCD is going to be x minus 3. I also know the restriction very easily. So the question is when is x minus 3 equal to 0? Now, most of you can look at this, and all of you should be able to look at this and find out what value of x makes it 0. Well, when x is what number? When x is 3, because 3 minus 3 is 0. 3 minus 3 is 0. But all you had to do was just take that denominator and set equal to 0 and solve for x. I'm going to add 3 to both sides, and I get x to be 3. So your restriction for number 2 is that x cannot equal 3. Okay? All right. Now, let's go ahead and rewrite this. I'm going to go ahead and rewrite this. So 3 divided by x minus 3 minus 4 equal x divided by x minus 3. All I did was I just rewrote the problem. So now I'm going to multiply both sides by the LCD. Now, since I have 2 rational expressions, I'm going to put that in parentheses. So times x minus 3 times x minus 3. Okay, just like that. Now I'm going to distribute. Okay, distribute here to get rid of the parentheses. So when I distribute, I get x minus 3 times the first rational expression, just like this. All right, minus 4, notice the parentheses, that's important, x minus 3. This times this is this, that parentheses was important, equal, and I'm just going to go ahead and rewrite this over. X divided by x minus 3 times x minus 3. Now I'm going to reduce. Remember, the whole point of multiplying each rational expression by the LCD is to clear those denominators. So the x minus 3's divide out, you get a factor 1. The x minus 3's divide out, you get a factor 1. And now what you have left is this. You have 1 times 3 is 3. Now be careful here. You're going to distribute the negative 4. A negative 4 times x is a negative 4x. A negative 4 times a negative 3 is a positive 12. Equal x times 1 is x. So I went from a rational equation to a linear. So I'm going to go ahead and combine like terms. So I get negative 4x, 3 and 12 is 15, equal x. Add 4x to both sides. Add 4x to both sides. This is 0. When I combine like terms, so I get 15 equal, that should be 4x here. 15 equal 5x, right? Then divide both sides by 5. Divide both sides by 5. 5 divided by 5 is 1. 1 times x is x, so I get x to be 3. Here's the problem now. This is one of my restrictions. So that means that this is not a solution to the original problem. So remember in our lessons we called this an extraneous, this is an extraneous solution. So some textbooks will say, we'll use the word false, it's a false solution. So see this 3, this x equals 3, it's a solution to this linear. So I want you to note, x equals 3 is a solution to the linear equation. But it is not a solution to the rational equation. And the reason it's not a solution to the rational equation is because it makes my denominator 0. 3 minus 3 is 0. 3 divided by 0 is undefined. Okay? Same thing here. So your answer in the blank right here where it says solution, remember right here it says if there are no solutions, just say no solution. So you're going to say no solution here. All right, and remember the LCD was x minus 3. So x equal 3 is an extraneous solution. So it's a false solution, meaning that it's a solution to this, but it's not a solution to the original because of the restriction, because it makes my denominator 0. All right, so you're going to say solution. You're going to say no solution. Okay, and the reason is because of your restriction. This extraneous solution here makes my denominator 0. Okay, so that's number 2. So just be aware of that. You can end up with extraneous solutions. Okay, and don't forget our solution here, number 1, I think was negative 3. All right. Okay, let's look at number 3 now. So number 3, we have this. In number 3, we have, let's see. Okay, we have x plus 5 divided by x minus 7 equal 10x minus 58 divided by x minus 7. All right, so the LCD is, notice that this denominator here is x over 1, so that denominator is 1, so I'm at least common denominator, and x minus 7 I cannot factor any further, so my least common denominator is x minus 7. My restriction, what can't x be? Well, what makes this 0? What makes this 0? Well, when x is 7. 7 minus 7, 0. 7 minus 7, 0. So x equals 7 is a restriction. Okay? All right, now be careful with number 3. So now we're going to multiply both sides by the LCD to clear the fractions. So notice I have two rational expressions here, so I'm going to put that in parentheses. X minus x plus 5 divided by x minus 7 equal, and I'm going to go ahead and rewrite this over, 10x minus 58 divided by x minus 7. So I'm going to multiply both sides by x minus 7. So times x minus 7 times x minus 7 in parentheses, just like I did. Now we're going to distribute. Now be careful with distributing. See, this is a binomial times this binomial here. So you need to rewrite it like this first. Say this times this. So say x times x minus 7. So this right here, this product, and if you need to cover some parts of this problem, if you need to cover it up, then you cover it up. So this times this is this, okay? All right, now minus this times this. So this times this. So minus x minus 7 times this. X plus 5 divided by x minus 7. Okay? Equal. Now over here, I'm going to go ahead and just right now go ahead and reduce. So this becomes, this right here becomes 10x minus 58. All right? So remember, the whole point of multiplying by the LCD is to make these denominators 1. So that's a 1 now. This is now a 1 because these divide out. Okay, but you got to be careful with the subtraction. Now right here, I'm going to go ahead and distribute the x. So I get x times x is x squared. X times a negative 7 is a negative 7x. Now be careful here. That subtract 1 times x plus 5. See, that's a subtraction. That's going to cause you an issue if you're not careful. If this was an addition problem, you wouldn't have any trouble. But the fact that it's a subtraction, you got to be careful. So what I would do first is this. I would go ahead, distribute like I did here, but right here I would be careful. I would say minus 1 times x plus 5. Put that x plus 5 in parentheses because x plus 5 is being multiplied by in this case, negative 1. Okay? Just like we did in number 2. Remember right in number 2 where we had minus 4 times x plus 3? We put that in parentheses. Okay? It's that same idea here. Same idea here. Equal, and then this is 10x minus 58. All right. Distributing here now, I get x squared minus 7x. A negative 1 times x is a negative x. A negative 1 times 5 is a negative 5 equal 10x minus 58. All right, combining like terms on the left side, a negative 7x and a negative x is a negative 8x. I get x squared minus 8x minus 5 equal 10x minus 58. Now I want you to notice this is a quadratic equation. This is quadratic. Okay? And the only way that you know how to solve a quadratic equation is by factoring. You're going to solve quadratic equations using a quadratic formula in the last part of the course. So in your course, though, all you've done with quadratic equations in terms of solving them is to factor. All right, so let's go ahead and bring all the terms to one side. Remember, to factor, we have to have 0 on the other side. So I'm going to go ahead and subtract 10x from both sides. Combine like terms. I get x squared minus 18x minus 5 equal, this is 0, minus 58. Adding 58 to both sides. Notice I'm combining my like terms. I get x squared minus 18x, and this is a positive 53 equal, and then that's 0. Okay? All right, so that's where I'm at. Okay, so I noticed one thing, guys, and you're going to make that same mistake if you're not careful. See this right here? I'm not sure why I put a subtraction. That's an addition problem. So that's an addition. That's addition. I'm so sorry. That's addition. And so this becomes 1 times x is a positive x right here. 1 times 5 is 5, so that's a positive 5. And then combining like terms, so this is all going to change. Let me go ahead and rewrite the rest of this. I apologize for that. I just don't want to go ahead and redo this whole 20 minutes over. All right, so this becomes, see, I made a mistake here, so that's plus. All right, so this becomes a negative 7x and a positive x is negative 6x. So x squared minus 6x plus 5 equal 10x minus 58. Okay? All right, now subtracting 10x from both sides, just like this, I get negative 6x and negative 10x is a negative 16x. X squared minus 16x plus 5 equal, this is 0, minus 58. Adding 58 to both sides, just like this, I get x squared minus 6x, and then 58 plus 5 is 63, okay, equal, and then that's 0. All right, now let's go ahead and factor. When I factor, to factor this, you're going to say x minus 9 and then x minus 7. Okay? So that's how you factor this. So x minus, that's 16 right here. So x minus 9, x minus 7. So if you check, the outer's a negative 7, the inner's a negative 9, you get negative 16x. And then negative 9 times negative 7 is a positive 63. Now setting each factor equal to 0, I get x minus 9 equals 0, x minus 7 equals 0, and so then I get x to be 9, and then x to be 7, okay? But remember, you gotta look at your restriction. My restriction is 7. So that means that this is not a solution. It's a solution to this quadratic, okay? But it's not a solution to the rational equation because it makes my denominator 0. See, 7 minus 7 is 0. So this right here, that is your extraneous solution. So you're not going to use it at all. Extraneous solution. So in terms of solution, you're going to say this. In terms of solution, you're going to say the only one is 9. That's the only solution. Just know that this is an extraneous solution. That's a false solution. Both of those are solutions to this quadratic. See this quadratic? Both of those are solutions to the quadratic, but they're not both solutions to the original. 7 is not a solution because 7 makes my denominator 0, so that's your restriction. All right. So, so that is the key to this worksheet. Just be careful. I'm not sure. Remember when I had subtraction here? Be careful. You're going to make that same mistake I made if you're not careful. So just be careful with writing things as you go along. Okay? All right. So that is the key to the worksheet called Extra number 9. Now remember the LCD here was x minus 7, and the only solution here is 9. All right. So that's what you write. Don't say anything else. The only solution is 9. Okay. So remember this right here is an extraneous solution. So this is the only solution. All right. So that is the key to worksheet extra number